Yes, recording has started. So it's operations research, and as I told you, though there are two words, operations and research. This first word, operations, has nothing to do with medical operations, though it can be used for hospital or medical related facilities for solving the problem. But these operations are related with the industrial or problem solving oriented operations. But of course, there is some history behind this particular subject, and because of that, that name is come into picture or existence. Operations and then research. So during World War II, military commands of UK and USA engaged the scientists to undertake scientific research into strategic and tactical military operations for taking decisions about optional utilization of scarce military resources and efforts. Okay, so uh, you might have heard about World War II and all these things. Uh, uh, Germany was attacking to UK. Okay, and then their fighter planes were coming to the country's area, and they are deploying their um, bombs, missiles, and etc. And they were coming in very directions and attacking the country. Okay, so there was a very great threat, and uh, the company's leader, country's leader, and all other military authorities got confused how to deal with this particular situation. The military personnel were definitely fighting these things, but then they thought that let us involve the scientists or mathematicians to get some solution for this particular problem or particular situation, to understand how and why, in what way and what directions this kind of attacks through fighter planes and all these things are coming. And we are having some scarce resources to fight against that. So how to utilize those scarce resources against them and create the win or to survive and to fight this particular scenario. And for that purpose, they involve the scientists and especially the mathematicians, and they try to collect the data. They collected the data related to these particular situations, rather World War situation, and then they analyze the data, and then they try to model it in some sort of mathematical model, and they try to develop some heuristics or solution methodology for that and prediction of the things, and then what will be the result. And they try to solve this problem by using some sort of programming, some sort of linear programming models, and then they try to use it, and some sort of, yes, results they got positively, and they could deal with that particular situation positively. And later on, what happened is that people thought that yes, this kind of mathematical models are possible for every situation, means like industrial scenarios, any organizational problem solving scenarios, wherever there are some sort of difficulties, problems, by collecting the data, formulating the defining the problem, formulating mathematical model for that particular problem, then searching for some solution methodologies, applying those solution methods, getting the results, implementing those results, and checking that whether improvement or problem solving takes place or gets solved or not. So that kind of thing come into existence. People started using it, and they nowadays it is used for any kind of scenario in the world. Even for day-to-day activities also, we can use operations research methods and techniques. And from that point of view, these particular models have been developed. Now there are based on applications, based on applicational areas, based on mm, identification of the problem or classification of the problem. These kind of models can be classified in a number of categories or a number of types. Out of that, the models which are important from managerial point of view, from mechanical point of view, from engineering and technology point of view are included in your syllabus. Apart from those models, there are other models existing. So what are the models which is included in your syllabus. Can you tell the topics which we have discussed yesterday one by one? What is the first topic? First topic is Introduction to Operations Research and Linear Programming Problem and Formulation of Mathematical Model. Okay, what is the next topic? Second topic. Yes, I'm expecting some answer from you people. Yesterday we have discussed it. Okay, so
Duality
solution
concept and
methods. Yes, yes, 207. Continue.
duality concept and integer
No, no,
programming.
no. I am talking about first module. In that there is another topic, that is solution methods to linear programming problems. And there are two solution methods. One is graphical method, another is simplex method, and that we are going to use. Then what is the next module? Is again having two topics. What are these two topics? Just now, as 207 has mentioned, duality concept and dual simplex method. That is another topic, or dual. That is one more model. Then third one is integer programming model. Fourth one, that is coming under module 2. What is included in module 3? Topic 6,
Transportation
5.
and assignment models.
Yes, transportation model is topic 5 and assignment model is topic 6. Okay, what is the next seventh one? Seventh is dynamic programming model and eighth is non-linear programming model. Okay, then ninth one,
Decision theory.
decision theory or decision models, and 10th,
Games theory.
game theory. It's game theory. Okay, or game theory models. And then what is the 11th?
Queuing model.
Queuing model or queuing theory model. And what is the last one?
Replacement.
Replacement model. So these are the models based on their application or problem identification or category point of view are classified and included. There are all other types of or kinds of models available. Those are not in the scope of our discussion for so far this subject is concerned, but they are existing as OR models. Okay, so that is all about the history of the OR and then OR models. Now, as I told you, yes, every problem can be, every situation, every scenario, everything which can be analyzed from engineering and technology point of view can be modeled as a mathematical model. Okay, and mathematics will help us to formulate it and solve it. Of course, sometimes or most of the times assumptions may be required for that, but those are required for simplifying some of the critical things. But then later on we can add those and we can go for making it somewhat complex and getting the solution. So that is there. And from that point of view, OR makes an attempt to find out the solution based on the mathematical model. Is it clear to you? Okay. So thereafter, the scientists and managers have started using OR techniques in the industries and also in academics. So we are following it and using it for solving the problems. The first mathematical technique called as simplex method, which is applied for linear programming problem, is developed in 1947, way back, by American mathematician George B. Dantzig. G. B. Dantzig. Okay, he is the mathematician who has developed a simplex method, which is a solution method for linear programming problem. And then uh, with evolution of this particular subject or topic or course, a lot of models have been developed. Lot of people contributed to develop some of the models as well as some of the methods or heuristic techniques to solve them. And based on their names, they have been identified, or sometimes based on the application or problem area, the name of uh, title or name to the model is given, or based on the how these models are categorized, based on that names are also given. So there are a number of models. and they are classified. We are going to discuss that classification as well. Now I will share my screen and give you some sort of introduction to the remaining part of the OR things. Okay, I think my screen is visible to you people. Is it visible?
Yes, sir.
Okay. So now, how to define the OR? People have tried to define the OR, and there are a lot of definitions available so far OR is concerned. You can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In 12 ways, people have tried to define it. Different people come up with different definitions. But we will consider a generic definition, the first one, which has been defined by Operational Research Society UK. So operations research is the application of the methods of science to complex problems in the direction and management of large systems of main machines, materials and money in industry, business, government and defense. Okay, so what is it? Application of methods in a scientific way to complex problems, getting some direction and solving managerial systems, which includes main machine materials and money, where in industry, business, government, and defense, and so on. Okay, so that way it is defined. The distinctive approach is to develop a scientific model of the system, incorporating measurements of factors such as chance, risk, with which to predict or compare the outcomes of alternative decisions, strategies, or controls. So ultimately, what we are interested in taking some decision, applying some strategies, applying some controls. So in order to take the decisions, you have to consider some measurement areas, factors, and on what basis they are there, and how to define and predict and compare their outcomes. That is important. And whatever alternative decisions are there, out of that we have to choose the optimum one and apply it. So ultimately, so far our scope of discussion is concerned, we are interested in solving it quantitatively, and ultimately we are getting some value, some quantitative information to a particular decision variable, and that decision variable is required to be implemented as a decision by the manager into industry or wherever it is applicable. Okay, so the purpose is to help management in determining its policy and actions scientifically. So that way the operations research is defined. There are other definitions as well, but definitely they includes all the things in the first definition. So I will not go into details of all other definitions. They are available in lot of books. Okay, then the operations research approach is problem solving approach, and for that there are certain phases to solve it. First one is judgment phase, second is research phase, and third one is action phase. In judgment phase, what is done is that we have to identify the real life problem, then select the objective with which it is required to be solved. What are the constraints and limitations within which we have to work? You have to identify that. What are the applicational areas? How to measure the things, that means constraint and related things, and what is the effectiveness with which it is required to be solved. That comes under judgmental phase. Then research phase. Now you have to collect the data related to the problem, observe all these things, analyze the data, formulate something related to that, what outcome we are expecting, then design or decide the decision variables, analyze the things, get the results, that means apply the models, execute the model, get the results, predict the results. After predicting or getting the results, implement it. That comes under action phase. Implement the results, take the feedback, whether you are getting improvement or solution to the problem or not. If not, change the model or modify the model. That way, in these three phases, the operations research work for problem solving purpose. And next, as I told you, there are n number of ways to classify the models. These are generic ways to classify the mathematical models, and they are equally applicable to the operations research models. So, for example, a degree of abstraction. Based on degree of abstraction, the models can be classified as iconic model, analog model, mathematical model. Likewise, even sometimes they are also classified as digital models. Okay, so for mathematical models are again classified like based on their behavioral characteristics, static models and dynamic models. They can also be classified like linear models or non-linear models. Static models may be linear, non-linear, dynamic models may be linear, non-linear. And then the, these particular type of models can also be classified based on degree of certainty with which the data is known to us related to the problem. So one is probabilistic model, another is deterministic model. So, so far deterministic model is concerned, we are knowing the data with certainty. So we have the related information, or we have the information related to the problem with certainty. That is deterministic model. But in probabilistic model, we don't know the data with certainty. We have to have the expected values or predict the data so that some sort of probability is required to be applied to the data. So they are called as probabilistic model. Most of the models which you included in your syllabus are deterministic in nature, and some or few, very few things we are discussing about probabilistic models. Otherwise, most of the things are deterministic in nature. Then based on the purpose, the models are classified like normative model and predictive model. Again classified as descriptive model and explanatory model. So these are the kind of models or types of models based on the purpose. And based on solution procedures, they can also be classified like analytical model and then simulation model. Whether we are going to use the analytical model and solve them by using some mathematical formulae and get the results, or we are going to simulate it and then get the results. The simulation may be experimental or physical simulation based on physical prototype, or maybe computer-based simulation. So that way we can go for classifying these kind of models. So these are generic. Some are other way the models classified. We are going to use it in our purpose for our discussion, for our study. Okay, so this is all about the classification of OR models. Now, as you are already familiar with the methodology, for example, machine designing. In machine design, for designing a product purpose, some sort of methodology is there and you are following it. Similar to that, there is a methodology for operations research to go for a problem and then to solve it. Okay, so this methodology starts with problem identification, or real life problem or opportunity. And we have to identify it, and then we have to clearly define the problem. Until and unless you clearly define the problem, you can't go to a solution of the problem. So in most of the time in life also, it is not that we don't know the solutions, it is that we don't know the problems, or it is not that we don't know the well defined problems. If it is well defined, then we can go to a solution. Okay, so after identifying the problem, you should have it a very defined or formulated problem. So after doing that, abstracting it, we have to go for identifying the system. That means choosing a particular aspect of reality which needs attention. Okay, where the focus is required, where the problem is located or required to be identified, and what are the areas required to be considered, and then define it clearly as a system. Then we have to go towards developing the logic, and based on that logic we have to go for developing the mathematical model. So for developing the mathematical model, a relevant data collection is required. Then we have to identify the variables. The variables or parameters may be constant, may be variable, or having some variations, or flexible. So you need to go for identifying parameters. Those are either constant parameters or variable parameters, and then assign them some sort of terminology so that they can be formulated with certain objectives. So for that purpose, we have to define some objective which is required to be achieved. Along with that, some constraints will come because of the limitation or limited resources. And then we have to identify the constraints as well. So objective function is one thing, and then constraint identification. Before that, you need to define the problem, identify the number of decision variables or decision variables, then identify the objective function, and then identify the constraints. So these are the three most important things which are required to be identified to get a problem, to get a mathematical model or to develop a mathematical model. Okay, why constraints are required? Because being as a human being, we are having limitations, or whatever thing we are doing, we are always having scarcity of resources. We never have infinite resources at our disposal. Okay, only God may be having it, we don't have. So for human being, there are limitations or scarce resources within which we have to work. Okay, otherwise the solution to the problem will be different if you are having infinite resources. Okay, then after developing the mathematical model, you have to think about solving the model. For solving it, you have to think of which particular solution method will be applicable for that, or what kind of heuristics or algorithms can be applied to this, and then selecting those techniques and applying them so that we can get some solution value to the decision variables. And then next step is testing the model and its solution. Then use those decision variable values in to implement them rather into the scenario which we want to solve, and put these values of decision variables to the model under consideration. See whether solution is valid or not. If it is not acceptable, then modify the model, and or you can choose entirely different model which will give better solution, and again do it iteratively. But if at all the solution is acceptable, then go for implementation. Okay, so before implementation, you have to test the model by implementing the results, decision variable values rather. Then you have to go for implementation and control. Once you implement it into the actual practice, interpret the solution values, then put the knowledge results gained from the solution to work through organizational policies. Then again, you have to monitor the changes, take the feedback, exercise the control, so that if at all any variation is there, you have to again go for solving the problem. If not, then implemented solution is, if it is better, giving some better solution or solving the problem, then that can be considered as a final solution. Is it clear to you, this methodology? Is it clear?
Yes, sir. Yes,
So
sir.
whatever model is there, whatever application is there, whatever problem is there, so far operations research studies concerned, this is the methodology gets applied to that. Okay, so knowing the methodology of research, operations research, you can understand what are the advantages of this particular subject, and or this particular methodology are related, or this particular study, what we can call it. So structured approach is there for solving the problems, and of course, if at all structured approach is there, then we will lead to certain solution or definite solution, or whatever solution we will reach, we have some sort of logic behind that, some sort of technique behind that, some sort of engineering and technical technological thinking behind that. That is important. So it is a structured approach to solve the problems, or to approach the problem, and so the error in this will be very less, or will not be detected easily. So that is the advantage. Then critical approach to problem solving. As analysis phase is there, and that too by using mathematics you are solving it, and we know the assumptions, limited constraints and objectives well beforehand, and we are critically analyzing this for getting the result. And if at all one or more of the values are changed, what will affect, how the results will get affected, that also we can analyze. That is called as sensitivity analysis. So that is possible. So it is a critical approach to solve the problem. So if variation in input data is there, what will be its effect the outcome or output parameter. That also can be judged, that also can be analyzed. So critical approach to solve the problem. So these are the main advantages of the operations research study. Of course, there are certain applications of this particular subject. So we are interested in studying and discussing this subject. So applicational areas are, for example, finance and accounting. At various points, various levels, it is required to be used or applied. And for marketing purpose, it is useful. And for purchasing, procurement, exploration of these things, vendor analysis, then transportation related things, replacement related things, we can go for applying this particular operations research subject and their models. In production management scenario, like facility planning, layout locations, then manufacturing areas where planning is required, assembly line is required, inventory control is required, R&D is required, payoff is required, budget and R&D calculations are required. So where it is applicable. Maintenance and project scheduling purpose it is applicable. Personnel management, HR management it is useful. Techniques of general management like management information systems and related things like decision support systems, it is useful. For forecasting and strategic planning purpose, this can be applied. Then in government organizations, for economic, for planning, for social planning, for using natural resources, for urban and housing problems, for military, police, pollution related data, it is useful and it can be applied. Though there are these many number of applications and again lot of applications we can think of in day-to-day life and apply it, but our scope will be limited to the models which are included in your syllabus, and that too again some of the basic things and then applying some of the methods and solving those problems by using those methods. Now most of the methods are iterative methods. That means you have to go and improving it. So you have to use lot of um, tables and situations and writing the quantitative data into that table, arranging it, rearranging it, then processing the data and again going towards solution in uh, iterative manner. So that way it is required. So that is all about applications of this particular problem subject, and then we are going to start our topic with model formulation. That too, firstly we will discuss the linear programming problem, its general structure, and then we will consider some of the cases and how to solve formulate those based on these cases. Are you getting me? Okay. Now, as whatever solution methods are there, they are mostly heuristic in nature. So, um, these solution methods can also be solved by using computers. Okay. Manually also we can solve it by writing them on notebook and solving it by applying the solution methods. But those solution methods can be coded and or even by using Excel sheet also, we can put them into some sort of coding, execute the code and get the result. So that way computers are contributing. Even some people have developed the OR softwares as well and they are using it in some industries or in foreign countries. But so far our scope is concerned, all the problems will be manually solved and you have to use pen and paper for writing those and solving them on the paper. Okay, so we are not going to use any software or codes for that, or algorithm will be there, but then we are not applying the codes for executing those algorithms. Is it clear to you? Is it clear?
Yes, sir.
Okay, so that is all
Yes, sir.
about the introduction to OR. I will stop my technical presentation here and then we will discuss the further part. Before that, how to stop the recording